Hi, today I want to pull the ALU back out and work on reintegrating that back into the build. My focus today is going to be on the flags, specifically the carry flag, but I'm going to drag everything else along with it. I want to make sure that I can still set and clear the carry flag and perform conditional execution based on the carry flag. That's going to be a big moment to make sure that I'm back up to the right spot. Timing is going to be a concern, and so I want to make sure that I get in and measure timing as best I can with a faulty oscilloscope. Now, I expect there to be a lot of troubleshooting today. I don't want to take away from that, so I have pre-set up some of the work that I'm going to be working on. I'll give you a tour of what that is here. Let's get into it. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, so here's the build largely as I left it at the end of the last video. I have done a few things though, and I want to kind of walk you through those here quickly. It did take several hours, and I didn't feel that this video needed to be a repeat of the last video. So what have I done? Well, I've added another control ROM board down here on the bottom, so those are these two, and placed in control ROM 8 and control ROM 9. And I wired up the latch as well. That's exactly the same as what I've got here, and here, and here, and here. So you've seen all of that work before. I've also extended down all of these address signals. I had to bring it from here down to here, down to here, and then I added in all the address lines into control ROM 8 and extended them over to control ROM 9. I think all told I've got some 6 hours into this build. Unfortunately, it was off camera, but fortunately it was off camera, which means that I don't have to put you through it again. We just did all of this in the last video. My test code is running, so you can see I haven't broken anything by doing this. And this now sets me up to be able to use control ROM 8 and control ROM 9 to be able to extend my ALU, which is not into the build yet. Now, my control ROM code will only produce output for 1 through 3 currently. I have room for 1 through 8. So I could easily produce output for all 8, and I'm going to do that in this video. I don't think I'm going to get into control ROM 9 yet, but in the next video or the next time I add anything to this, I am going to have to overhaul the control ROM build to handle more than 64 bits. Yeah, I'm going to be pushing 80 or 120 bits worth of control ROM signals by the time this is all done. So I'm not exactly sure what all those are yet, but I am working towards that. Okay, so this is what I did off camera. Let me pull out the ALU. I'll slide everything over a little bit, maybe have to zoom out, and I'll stick the ALU over here, and we'll start figuring out what it takes to get wired up here. I'll be right back with that. Okay, here is the ALU as I left it. It sits over here. I'm specifically looking at the flags today. So basically we're looking at everything from here up. The stuff that is down here we're going to ignore today. I just don't want to separate out the build just to turn around and put it back in. I did take some time to review my old design notes, my videos, frankly. There are 20 signals that I need to connect up just to get the flag management portion here working properly. 10 of them are going to be associated with latch control, and those are here and here. So without my big club fingers. So these 5 signal lines here that are not connected are for the program latches for each individual flag. And then I've got interrupt copies of each one of those as well. So those will be connected up. Here I've got clear or reset. I've got the X for context flag, clear carry, and set carry. Those 4 signals are actually sitting across 5 different rows in this breadboard, so I'm going to kind of clean that up so I only use 4. Up here I have my input, so I've got the 4 different signals that are coming off the 4 most significant bits here of the fetch register, which then should take care of selecting which flag result is appropriate for conditional execution. Then I've got the clock here for latching, so I can latch what the flag state is and use that for the proper clock cycle. And finally, bit 14 of my address into the EEPROM needs to be taken from the output result here, I believe. I have to double check the pin diagram. But the output result of this 151 needs to come back over here and drive the address lookup of this logic. Now in video 56, I tried to do that with instruction suppress, but that wasn't going to work. So I do want to make sure that we get that dealt with properly here as well. Again, I've done some work off camera. I've got several different hookup wires that I've put together, and I will use those to try to get these all hooked up. The 4 inputs are already wired here and are hanging out this side of the breadboards, and I need to relocate that back over to here. So I will start with moving that. So my clock I'm picking up here and driving that over here for my latch. So my output of the flags result evaluation here, which is here on pin 5, comes back over here to bit 14 up here. And 14 is pulled low explicitly down here. I'll remove that. Okay. And then I've got my control signals, which are wired down here. Now, the upper 5 I'm not going to use right away because that's for the interrupt context, but my lower 5 for latching, I will tie into my control ROM here. And I don't want to do that directly, so I will build another cable to come out and around. That's one cable I did not make yet. There's a few things I can wire up here knowingly. Clear should be here, and I can pull that from my signal up here, which is already doing the clear. X, which is my context, will be tied low for the moment to indicate that I am in a user context or a program context. And then the other 2 control signals here are going to come off the ROM. And I need to make the cable that I need to come around this way. Okay, while I'm off making this cable, let's talk a little bit quickly about what Control ROM 8 is going to look like. The top most significant bits are going to be used for clearing and setting the carry flag. And then I've got 5 bits for latching each of the individual flags that I'm maintaining. Now recall I introduced the concept of an L flag in my ALU design. I'll put a link to that video as well. And then these are going to be largely duplicated for the interrupt context. So these are just the normal program context. Each of these signals need to be NANDed with the clock so that in its natural state, that signal is high. The beginning of the clock cycle, the signal itself comes low and it's on the rising edge that the latch is performed. Well, Adam, how does that address clear carry and set carry? Well, I want those to be treated and happen at the same time as the latch. Both clear and set are asynchronous, so I don't need a latch in order to make that change, but I want them to be congruent signal-wise with the latching of a flag from a prior instruction. So with that, all 7 of these signals will be NANDed together with the clock, and I'll build that out for Control ROM 8. Let me get right into that. Oh, by the way, while I'm here, you may be wondering what is earmarked for control ROMs 4, 5, 6, and 7. And these are all the different things that would be loading off of the main bus. And there's quite a few of those. So that's what those ROMs are earmarked for, is controlling the signal for loading. A huge thank you to Dave Jones. Between me recording the last segment and now, he promoted my channel for me on Twitter, and I do appreciate that. If you're here because of that, thank you so much and welcome. Okay, now with that, my least significant bit is down here. My most significant bit is up here on this side. Here's where I pick up the signals I'm going to use, wrap those around. I'm going to drop them in. Let's drop them in here. It should be, it's tight to see down here, so I'll zoom down probably. But this is where I'm going to do most of my connections, is between this and this, way down here in the bottom. All right, give me a second to reset here so we can look at what those are going to be, and we'll start hooking those up. Okay, I'm zoomed down here pretty good. The area I'm going to focus on is literally this small little section of this breadboard here in this entire huge build. Specifically, I'm going to be taking jumpers from this connector that I just added to these two connectors, which run off to the flags on the ALU. These signals here are set carry, clear carry, my X flag, which indicates what context I'm in, and then my actual reset, which should be resetting the flags back down to 0. So and I've got some notes off to the side over here, set carry is this signal here. And if you look at the code over here on this side, set carry is bit 6. So that's going to be that connection there. The next one over is clear carry here, but that is the most significant bit there. Then I've got here the 5 latches, and 0 should be the least significant bit here. So bit 5 here should track over to this. Bit 4 should be carry. Negative should be the next one over. Overflow. And then my purpose-built less than flag, so that I can control the latch of that as well. Now notice down here, there is one bit that has not been connected, that is unused at this point. And as a matter of fact, right about there in the comments, it indicates exactly the same thing. Bit 0 is unused for now. The other thing to call out here is that these 5 signals down here on this ribbon cable are not connected. Over on my ALU, I'm using all LS logic, some HCT, but everything is coming into LS. I believe I should be good with that. It should, because LS has internal pull-up resistors, I don't expect there's going to be any problems with that. The pull-up resistors will take care of settling that signal. I will end up adding these when we get to the interrupt controller. There are some additional changes I need to make to the code here. Right now it only outputs 3 ROMs worth of data. I need to update that so it outputs 8 ROMs worth of data. I actually need to build that and write all the ROMs. So let me get that taken care of. I'll do that off camera. I'll reset the builds and zoom back out again so we can perform some testing. I'll be right back. All right, let's see here. Control ROM 1, 2, 3, and 8 have all been reprogrammed. 4 and 9 are not being used at the moment. I've got all my hookups taken care of here. I'm not using the lower portion of the ALU yet, just the flags portion. I did double check VCC and ground to make sure that they were not shorted. And I still have the old code in here. I have nothing to test clear carry and set carry yet. I just want to make sure that things work the way that I left them. All right, let's try power. Let's go for broke here. That appears to have reset properly. But amazingly enough, I just realized that I never hooked up power over here onto this board. So I got signals running to it, but it can't do anything with it. Let me remedy that real quick. I've got 2 connection points here. I believe that should be sufficient. We'll see if that works or not. Let me try a reset again. This I'm not worried about. That I'm not sure about, but let's see if I step through if everything else still works. Okay, that's working just the way it should. Okay, perfect. Now I need to write some code to exercise this carry flag a little bit. Let's see what comes out of that. Well, I suppose this probably requires a bit of a code review. This is the test program that I wrote, which is basically going to play with the carry flag and some conditional execution based on the carry flag. Now, I'm specifically managing whether the carry is set or clear, and then running some tests so I can determine if things are actually working or not working properly. So I start off by setting the carry, issuing a couple of no ops, clearing the carry, issue a couple of no ops. That's just to make sure that the carry flag itself is being set and reset properly, giving me an opportunity to look at that and confirm that that's happening. Then I make sure that the R1 register is clear. And conditionally, if carry is clear, which it should be, I then turn around and set it to all Fs, meaning that all the LEDs are going to turn on. Without having changed carry at all, I do a move into R1 of some alternating values. So I should see that. That instruction should not execute, but if it does, I should see it. And then I set the carry flag and immediately turn around and on the next instruction do a move setting everything to be alternating. And then clear carry again and immediately turn around and try to set it to a totally different value where each nibble is alternating, but the nibbles are alternating. Say that 3 times fast. So basically, the challenge here is to make sure that I'm actually getting the conditionals executing properly, evaluating properly, and when a condition changes and an execution is conditionally dependent on that change, I want to make sure that I'm getting the correct timing. So I want to do it both. Yes, it passes, and no, it never passes. And finally, I've got some tests down here. Now they're a little bit late, but I do want to take a look at them to make sure that a single instruction, a single word instruction is handled properly, and a 2-word instruction is handled properly when the condition is met, and similarly when the condition is not met. Now, to make this work, I did also make some changes, or make a small change to the architecture file of the assembler, and I moved the clear carry set carry up into what I believe will be its permanent home. But last I had to make some additional changes to the control ROM. So if you look, I've got a move into R1, a 16-bit immediate value. So I'm now looking to see if I've met the condition, and if I do meet the condition, in that particular case, I am returning a no op or with instruction suppress. And so what I need to do is I need to not do anything for the instruction that's in the instruction register, but I also need to not do anything with the instruction that's in the fetch, because that's not really an instruction, it's a constant, and I don't want that being executed as if it is an instruction. So that should take care of my 2-byte or 2-word instructions. All of those have similar returns when I don't meet the condition or the condition flag is set, meaning I failed the condition evaluation. For the single bytes, it's real easy. I just executed no op. Okay, I've got a lot of EPROMs to program, and then we'll give this a test again. Programming is done. I did notice one thing up here, and that is, well, I'll stick code up here on this side because I don't think I'm going to be doing much messing over here, so it shouldn't get in the way over there. Most of my focus is going to be on this section of the build. But with that code up there, what I did notice is that the selection between set and clear is actually the least significant bit here. So if I flip that around, that'll be appropriate, with the red mark here being the least significant bit. With that code up there in the corner, power on, everything looks like it reset properly. I'm still in reset. So I have a voltage problem here. Yeah, it's not coming back above 4.86. All right, well, let's solve that voltage problem first. The first order of business here is to add additional power connections to the ALU, since that was the last thing I added to the circuit. Okay, that worked. Still 4.83, but it was enough to pull it out of reset. Means I'm right on the operational limit here. It did not pull it out of reset. I'm just checking to make sure they all have capacitors. It did finally come out of reset. That is taking some time to come out of reset. I'm still poking around looking for a smoking gun here. I'm definitely getting to be on the verge here of critical mass. Now, I did not anticipate having these problems today, but I'm happy that I took care of as much as I did off camera so that I had a little bit more time and not so much pressure to feel like I had to get things solved quickly. I am not completely certain how to solve this other than to get some massive power distribution wired up or bump back up to my 5.2 volt power supply rather than the 5.0 volt power supply. Now it's a relatively simple change to switch over. I've got the connection right here. I guess the question is am I pulling more amperage? And the answer is probably yes. But am I pulling more amperage than the... No, that still doesn't come out of reset. And that's on 5.2 volts. So something in here is dragging this down. I don't know what that would be. All right, I'm gonna have to do this somewhat methodically. So let's pull power out and disconnect this other board here. And that comes out of reset right away. And go back to the one I can control just a little bit easier. Immediately out of reset. Okay, so now if I hook this up and I want to pull power here and that should effectively cut off the bottom half of this build from what's being powered, and immediately right out of reset. Let's pull these LEDs out. Stays in reset a little bit longer, but it does come out of reset. Okay, so with power disconnected from here down, it comes out of reset right away still. Okay, these two boards are now disconnected, and it still comes out of reset right away. Okay, now this bottom board only, and that takes a little bit longer to come out of reset. I'm going to just disconnect that, and I'm going to kick that can down the road so that we can move on here. Let me get power and ground hooked back up, and we'll see what we can do to actually do some testing. Okay, all right, that's good. All right, let me put the code back up here in the corner. The first instruction is set carry, so that's 000F, which is accurate. I move that up into the instruction register, and I'm expecting, not exactly sure which one, I believe it's the third one from the left, a light to come on when I clock this, and it did not. So, next problem, are my signals actually making it to the board here? Okay, I start by checking the signals. They're not right. So I trace back to the ROM, control ROM 8. The signals aren't right there, but the address is not right. And finally, I realize that the program counter is not incrementing properly. So let's start with that. Something is not incrementing properly. So I changed something in the code. So program counter is not incrementing. That's my next problem to solve. Well, one way or another, I believe I've found a bug in the C-Lang compiler. Let me explain. Before I had my enum set out, I had no underlying type defined. I ended up adding that in order to get the full 64 bits. The compiler itself didn't complain about me shifting past the size of an integer. So when I added the underlying type explicit definition, it now started complaining about me shifting past the end of the register. And so I had to go and explicitly type each one of these constants that are being shifted. So using R12 load as an example, binary bit 1 needed to be explicitly defined as an unsigned long before I shifted it to the left 6 bits to align it within the byte, and then an additional 32 bits in order to align it within the actual 64-bit integer. The compiler, using this explicitly defined underlying type, should have typed every one of these constants the same. And I believe that to be a bug. Well, either way, I believe it to be a bug. Either it should have typed those properly and didn't, or should have complained to me about me shifting an integer off the end and didn't. And so I'm annoyed with that. Unfortunately, G++ or GNU GCC, it works exactly the same as CLang, so I believe that to be a problem in both compilers, really. Anyway, long story short here, I discovered that Control ROM 2 had that extra byte inserted issue, and then Control ROM 8 had no data on it. Everything was zeros, when this is where my signals for clear carry and set carry are mapped to. So having reprogrammed this and having reprogrammed this after fixing the issues in the source code, I believe I am ready for another test. Give me a minute to straighten up my mess here, and we'll give this a shot. Okay, let's go find the next problem. I'm going to put the code back up over here again, and here we go. I did get the increment happen here. My zero flag came on, which is interesting. This is the set carry, 000F. I'm going to know up behind it. So I am expecting this LED is not used. That's the zero flag. That's the carry flag. I went ahead and labeled that. And that did not work. So setting the carry flag did not actually happen. So let's see here. It looks like these two might be backwards. So let me try that again. So that should be set carry. And that set the carry, so that's good. But it reset it. Do I not have the right signals going to that 74 LS74? Because it's not latching. I never sent the signal to latch. But yet it resets or sets the carry, but it doesn't maintain that. Let me pull up the data sheet and take a look. Okay, so the 74 LS74 does not require a latch for set and clear. They should happen independently. But it looks like I may have both preset and clear signals low if I look at the function table. They both might be low, which would require that the output go high and is unstable. So let's probe that. So this is the one for carry, and pin 1 is clear, and clear is always low. That is finally working properly. So set carry now is working, and my problem was twofold. I had incorrectly switched these two signals here, and my reset signal is not correct. So the problem here is that this signal is an active high signal, meaning that what's coming off of, or what's coming into my reset, is high when we are resetting. This wants an active low signal. And so what I need to do is I need to actually pull that signal, and I'm going to pull it off the inverted Q output of my reset latch. So that should come over there, and that way when I reset, it clears. There's my set carry, and it's already setting it. That seems to be somewhat working. I'll reset for another test, and we'll get a little bit deeper into the conditional execution, assuming I get to that point. Okay, let's reset and try again. So the first instruction here is set carry, which has performed that function, which is good. I've got 2 no-ops. My carry flag persisted through those, which is good. This is a clear carry, and that properly executed that as well. 2 more no-ops, and that's good. Now I'm going to force a value of 0 into R1. It's already empty, so these two instructions aren't going to do very much. Next up is a conditional here, and it is move into R1 all F's if carry is clear. So carry is clear, therefore I do expect it to perform that move. So there's the move, there's the constant, and it did not perform the move. So my condition failed. Ah, that's the problem. This needs to be plugged in here so that I've got a proper exclusive OR of that condition. Let's try that again. Okay, that's low. That says that the condition should be met, and that worked properly. The next instruction is if carry is set, carry is not set, then I'm going to move an alternating pattern of bits into R1. And this should not execute. I do not expect to see that pattern show up over here. And it did not. And as a matter of fact, a no-op moved up into the instruction register. Set carry. And then move if carry is set, an alternating pattern. So here's the alternating pattern. I am expecting to have that show up in R1, and it did not. Curiously, different pattern to show up here in R1. This is supposed to fail, but it did not. So when I have a no-op in between, it works. If I remove the no-op from in between, the signals don't have enough time to settle in order to select the correct code on the ROM. Okay, I'm going to have to think on this a bit because I have a feeling that my problem actually exists with this latch. Okay, zooming in up here just a little bit, let me explain what I believe the problem to be before I start making changes. These 12 signals here run off to the EEPROMs off the right-hand side of the screen here to select the address that is going to be used to determine what the control word is, and that control word is latched at each ROM. These signals are picked up ahead of this latch here so that the ROMs have an opportunity to settle, and then the output is latched at the same time that the instruction is latched up here so that we've got the output and the signals congruent with each other. On the other hand, this signal here, so this is the condition met signal, is also part of that address chain over here, but it is determined and prepared after the latch, not before the latch. So I honestly believe that all of my different signals here on this multiplexer, which are picked up after the latch, need to be redone so that they all come before the latch. And that may render this latch totally obsolete, meaning I don't believe I'm going to need that. What I need to do is I need to pull out some of these connections here, rewire it temporarily so I'm picking it up ahead of the latch. And if that works the way that I want it to, then turn around and reset this so that the latch is no longer in play, because I don't believe anything really is required. Well, I take that back. I've got a carry flag that may end up being as a carry input, so I may have to latch it just for carry. Well, I got those all messed up, didn't I? All right, I'm going to have to double check now and make sure that I got all that right because confidence is low. Okay, here is that 74 HC or LS151, and data pin 0 is supposed to be tied high. And so that's tied high. Data pin 2 is supposed to be coming from Q2, which is the 0 flag. Now the 0 flag traces back here to what is the green here. So this is the 0 flag coming up, and one of them is the 0 flag, one of them is the inverted 0 flag. I'm going to call this the 0 flag because the stuff on the right here is inverted. That looks correct. That's data pin 2. Sorry, data pin 1. Data pin 2 comes back to the carry flag, so that should be the next one over. So carry is here, it is in orange, And that is indeed, it's very close, very tough to see, but right in here is the carry flag. So that should be this red one. That's good. The next one over is the N flag. That should be these brown signals. There's a brown signal that comes up next to it, so that's there. That's correct. So it's the next 4 that I think I messed up pretty badly. 4 is coming off the V flag. Now the V flag is over here in the purple, and that should be the next one over here, which is good. And that needs to go to data pin 5, which it does. So I do have that correct at this point. No, it's data pin 4, not data pin 5. The next one over is ANDed between the N flag and the not Z flag. So that AND, that might be correct. That looks like the result of an AND. I'm going to assume that's correct at this point. The next one, 6, is the inverted L flag. L is over here with the blue. So this one then is my inverted, and that is correctly wired up to, okay, I have those correct. Now I need to reset and go back to the full view so that we can see what's going on, and with any luck, this will work. Be right back. All right, let's try this again and see what new treasures I can uncover. There's my carry flag. We undid the carry flag, forcing a 0 into R1, which is good. Now the next instruction is a conditional move, which should execute, filling this register with all the LEDs on. That's good. This instruction is a conditional move that should not execute. So I am not expecting R1 to be updated with that pattern, and that's good. Now I'm setting the carry flag, so I've got a known condition here, and I'm conditionally executing if carry is set. This is the one that failed last time. Again, an alternating pattern here, and I'm expecting this to go in here, and it did. That's good. Now I'm going to clear the carry, and then this is a move into R1, a different alternating pattern, and I am not expecting this to execute, and it did not. All right, now I've got some checks of single and 2 bytes or 2-word instructions. So to set that up, I turn carry on. I'm going to move this value into R2 when carry is set, and it is set, so I do expect to see that move happen, which it did. Now I've got to move conditionally into R2 of a constant of 0. So, and that is if carry is set. Carry is still set, so I expect this to be cleared out, which it did. Now finally, if carry is set, it's conditionally clearing carry. That's good. And then I repeat the same moves. So when carry is set, which it is not, this should not be moved down here. And it did not. And then this should not load with 0. It's 0. It's probably a malformed test, but nothing's changed, so that's good. Finally, I have turned carry on if carry is set, and it is not, so that's good. I have a jump if carry is set. It should not jump, so my jump is back to 0, so we'll watch the program counter here. That did not jump, so that's appropriate. Now I have a jump if carry is clear, which is here. Back to address 0, so we'll watch here, and that did jump. And now I've got my set carry. Now, I believe I might still have one final problem to look at here, and that is that this is executing as soon as it hits the instruction register here, rather than executing on the way out, meaning these may need to be driven not by the clock but the inverted clock NANDed over here. I want to just try a quick change on that just to see if that's going to give me slightly better behavior, because I'd rather have it clear and set when I do the clock cycle as opposed to executing as soon as it hits the instruction register. That's floating. Let's start with this and see if that will fix my problem. It will not. So now let's try this with the inverted clock. That's what I want to see. So I've got some cleanup to do over here because the top two signals I want to have driven off the inverted clock. I've got this one chained off to this latch, so I'm going to have to reset that back here. So let me have a minute to clean that up, and we'll give that a shot again. Okay, while I'm doing the final cleanup up here in the corner, I'll take a moment and wrap up because unfortunately, as has been lately, this video was longer than I intended it to be. After doing the cleanup, everything tests out perfectly, so you've seen that already, and there's no reason to repeat that. I do still have one concern that needs to be handled, and that is the power problem that I discovered. I did kind of postpone dealing with that this video, and we'll have to deal with it next video because the intent is to get those two boards that I removed hooked up and actually start adding numbers together. And that's a huge milestone for this build. So I can't hook them up and add numbers if I've got power problems when I hook them up. So that is the next video. I am planning on adding two numbers together and being able to use the carry flag in order to add into that as well. And I need to construct some good tests for that. So look forward to that as well. With all that said, we'll see you soon.